Hi, I'm Nikee Shrestha, a FFAR fellow from University of Nebraska-Lincoln. The cornfield that we see when driving across the Midwest is filled with the best chosen corn. And you might be thinking, how can you choose the best corn among corn, because it's all corn. So that is where the genetics comes in. Just like you and me, we both are human but have different eye colors, hair colors because we have different genetics. So in plants as well, if two corn plants have different genetics, that makes them different and are called different genotypes. So for plant breeders, the key is to choose the best corn genotype suited for a particular location and release it to the farmers as variety. Because one genotype that performs very good in one location may perform worse in another location. So that is why this never-ending process of variety development requires growing thousands of genotypes in multiple locations and measure how each of those genotypes are doing, and also mainly measure yield, which in research is called field phenotyping. However, field phenotyping is considered one of the biggest challenges in plant breeding because of time, cost, and labor. Currently, researchers use technologies, one of them being drone flights. So instead of manually going inside the field and measuring their phenotypes and measuring their yield, these drone flights are used to capture the image of whole field, and those images are instead used to estimate their yield and also see how each of those genotypes are doing. And this does help a lot, but still it has some limitations because it still requires a trained pilot to be physically present in the location, and in some cases like remote location it is impossible. So that is where my research comes in. My research explores expanding the field phenotyping through imaging without actually being present in the field. That would be through the use of satellite images. Satellite images can capture the image of huge field in just seconds, and it can do that in any part of the world. And the good news is we already have a lot of satellites up in the space, which we are using daily in our life. One common use is Google Map. So just like in Google Map, but instead of mapping locations through the images, I use satellite images to map the cornfields with different genotypes. And in my research, we saw that even though the satellite images have much less resolution than UAV images, it can still capture the difference between genotypes in very small plots. And we also developed the process where we can map those plots with different genotypes and actually use those images to even estimate the yield, the thing that we all care about. And this is good because now breeders can expand their breeding experiment to more locations than what is now possible, and then choose the best corn genotype for our farmers. Thank you.